White matter of the spinal cord contains myelinated nerve fibers having the same function, origin, and termination are grouped to form tracts. The tracts are either short or long. Both short and long tracts are ascending or descending. Short tracts begin and terminate in the spinal cord. Their functions are association and coordination. Long ascending tracts carry different types of sensation either to the cerebral cortex if they are conscious, or to the cerebellum or brain stem if they are unconscious sensation. Descending tracts, on the other hand, are motor in function, arise from the cerebral cortex or subcortical areas. Those arising from the cerebral cortex descend to terminate in anterior horn cells of the spinal cord, pyramidal tracts, either crossed or direct, or motor cranial nuclei in the brain stem, corticobulbar tracts. Those arising from the subcortical areas and nuclei in the brain stem are called extrapyramidal tracts. Ascending tracts carry different sensations, proprioception, pain and temperature, and simple or light touch to the cerebral cortex, conscious, or to the cerebellum or brain stem, unconscious, through three-order neurons. The first-order neurons are present in the dorsal root ganglia. The nerve cells are pseudo-unipolar, carrying impulses from the sensory receptors, then enter the spinal cord and synapse with the second-order neurons. For conscious level of the three types of sensation: proprioception, large cells present in the dorsal root ganglia with thick myelinated nerve fibers enter the dorsal column of the spinal cord through the medial division of the dorsal root. For pain and temperature, small-sized cells present in the dorsal root ganglia with thin myelinated nerve fibers enter the dorsal column of the spinal cord through the lateral division of the dorsal root. For simple or light touch, medium-sized cells present in the dorsal root ganglia with medium-sized myelinated nerve fibers enter the dorsal column of the spinal cord through the lateral and medial divisions of the dorsal root. The second-order neurons are present in the sensory nuclei in the gray matter of either the medulla, gracile and cognate nuclei in case of proprioception, or in the spinal cord, substantia gelatinosa oblongata in case of pain and temperature, or main sensory nucleus in case of light or simple touch. The third-order neurons are present in the posterolateral ventral nucleus of the thalamus, which pass to sensory areas of the cerebral cortex. Proprioceptive pathway. Proprioceptive impulses from muscles, tendon spindles, Pacinian corpuscles, and mechanoreceptors are carried to the cerebral cortex, conscious level, or to the cerebellum and the brain stem, unconscious level. These sensations are the sense of position, movements, vibrations, and pressure. Also, the sense of fine or deep touch, tactile localization, and tactile discrimination and stereogenesis. For the conscious level, proprioceptive pathway is carried through three-order neurons. The first-order neurons are large cells present in the dorsal root ganglia. Its thick myelinated nerve fibers enter the dorsal column of the spinal cord through the medial division of the dorsal root and ascend in the spinal cord and are termed according to the area of the body from which they carry proprioceptive sensations. Gracile tract carries proprioceptive sensations from the lower half of the body, sacral, lumbar, and lower thoracics, and it is present in all levels of the spinal cord, and ascends as gracile tract, which terminates in the gracile nucleus in the dorsal part of the closed medulla at the same site. Cognate tract carries sensations from the upper half of the body, upper thoracic and cervical segments, and ascends as cognate tract to terminate in the cognate nucleus in the dorsal part of the closed medulla at the same side of the body. Second order neurons are the cells of gracile and cognate nuclei present in the dorsal part of the closed medulla at the upper level. Their axons divide into external arcuate fibers which relay in arcuate nucleus in the anterior part of the open medulla close to the pyramids. Then go to the cerebellum through the inferior cerebellar peduncle, and the internal arcuate fibers which cross to the opposite side at the sensory decussation and ascend as the medial lemniscus. Termination occurs in the posterolateral ventral nucleus of the thalamus, which is the third order neuron. Third order neurons are the cells of the posterolateral ventral nucleus of the thalamus. The axons of these cells enter the sensory radiation to end in the sensory area of the cerebral cortex. In the head and neck, ascending tracts carry different sensations are carried through trigeminal nerve fibers to the nuclei of the trigeminal nerve. For proprioception, the first order neurons are not present, as the nerve fibers enter directly the bones and relay in the mesencephalic nucleus, which is the second order neuron. Second order neurons are the cells of the mesencephalic nucleus in the bones. Their axons cross to the opposite side and ascend in the trigeminal lemniscus to join other sensations from the head. Termination occurs in the posteromedial ventral nucleus of the thalamus. The third order neurons are the cells of the posteromedial ventral nucleus of the thalamus, whose axons end in the sensory area of the cerebral cortex. Other proprioceptive impulses not reaching the cerebral cortex are the unconscious level. They are located in the lateral column and are carried in three order neurons. The first order neurons are large cells present in the dorsal root ganglia. Their thick myelinated nerve fibers enter the lateral column of the spinal cord through the medial division of the dorsal root, ascend in the spinal cord, and are termed according to the area of the body from which they carry proprioceptive sensations. Ventral spinocerebellar tract. It is like a gracile tract, carries sensations from the lower half of the body, and is present in all levels of the spinal cord. It enters the spinal cord and terminates in the Clark's nucleus of both sides, the same and the opposite side. Dorsal spinocerebellar tract is like cognate tract. It carries sensations from the upper half of the body, enters the spinal cord, and terminates in the Clark's nucleus of the same side. Then spino-olivary tract is formed of collaterals from gracile and cognate tracts to the main sensory nucleus, which is the second-order neuron. Second-order neurons for unconscious proprioception are the cells of Clark's nucleus and main sensory nucleus in the posterior horn of the gray matter. For the ventral spinocerebellar tracts, the Clark's nucleus axon ascend in the lateral column as the ventral spinocerebellar tract and enter the cerebellum via the superior cerebellar peduncle. For the dorsal spinocerebellar tract, the Clark's nucleus axons ascend in the lateral column as the dorsal spinocerebellar tract enter the cerebellum via the inferior cerebellar peduncle. For the spino-olivary tract, the main sensory nucleus axons cross in front of the central canal of the spinal cord and ascend in the lateral column as the spino-olivary tract, to terminate in the inferior olivary nucleus in the open medulla, which is the third-order neuron. Third-order neurons are the cells of cerebellar nuclei in the ventral and dorsal spinocerebellar tracts, and the cells of inferior olivary nucleus in the spino-olivary tract, which sends fibers, olivocerebellar fibers, to enter the cerebellum via the inferior cerebellar peduncle. Pain and temperature pathway. Pain and temperature impulses from free nerve endings and perhaps mechanoreceptors are carried to the cerebral cortex, conscious level, or to the brain stem, unconscious level, through three-order neurons. Pain and temperature, conscious level. The first-order neurons are small cells present in the dorsal root ganglia. Their thin myelinated nerve fibers enter the dorsal column of the spinal cord through the lateral division of the dorsal root, ascend or descend in the spinal cord for one or two segments, making Lissauer's tract, found at the tip of the posterior horns in all levels of the spinal cord. Finally, Lissauer's tract terminates in substantia gelatinosa of Rolando, at the same side, one or two segments above or below the level of origin. Second-order neurons are the cells of substantia gelatinosa of Rolando. The nerve fibers cross to the opposite side, ventral to the central canal of the spinal cord. The tract then ascends in the lateral column of the spinal cord as the lateral spinothalamic tract, deep to the ventral spinocerebellar tract. In the pons, however, it unites with the ventral spinothalamic tract, forming the spinal lemniscus. Termination occurs in the posterolateral ventral nucleus of the thalamus. Third-order neurons are the cells of posterolateral ventral nucleus of the thalamus. Their axons enter the sensory radiation to end in the sensory area of the cerebral cortex. Pain and temperature from the head and neck. is carried through the trigeminal nerve fibers through three order neurons. The first order neurons are nerve cells in the trigeminal ganglia. Their axons enter the pons, descend and relay in the descending spinal nucleus, second order neuron. Second order neurons are the cells of the descending spinal nucleus, present in the pons medulla, and is continuous with the substantia gelatinosa of Rolando. Their axons cross to the opposite side and ascend in the trigeminal lemniscus, join other sensations from the head. Termination occurs in the posteromedial ventral nucleus of the thalamus. Third order neurons are the cells of posteromedial ventral nucleus of the thalamus, whose axons end in the sensory area in the cerebral cortex. Simple or light touch. Simple touch impulses are carried to the cerebral cortex conscious level or to the brain stem unconscious level through three order neurons. For conscious level, the first order neurons are medium-sized cells present in the dorsal root ganglia. Their medium-sized myelinated nerve fibers enter the dorsal column of the spinal cord through the lateral and medial divisions of the dorsal root, ascend in the spinal cord for one or two segments to terminate in the main sensory nucleus at the same site, one or two segments above the level of origin. Second order neurons are the cells of main sensory nucleus in the posterior horn of the gray matter. Their axons cross to the opposite side, ventral to the central canal of the spinal cord. The tract then ascends in the ventral column of the spinal cord as the ventral spinothalamic tract. In the pons, however, it unites with the lateral spinothalamic tract, forming the spinal lemniscus, which ends around the cells of the posterolateral ventral nucleus of the thalamus. Third order neurons are the cells of posterolateral ventral nucleus of the thalamus. Their axons enter the sensory radiation to end in the sensory area of the cerebral cortex. Simple touch from the head is carried through the trigeminal nerve fibers through three order neurons. The first order neurons are nerve cells present in the trigeminal ganglia. Their axons enter the pons and relay in the main sensory nucleus, the second order neuron. Second order neurons are the cells of the main sensory nucleus present in the pons. Their axons cross to the opposite side and ascend in the trigeminal lemniscus to join other sensations from the head. Termination occurs in the posteromedial ventral nucleus of the thalamus. Third order neurons are the cells of posteromedial ventral nucleus of the thalamus, whose axons end in the sensory area in the cerebral cortex. Unconscious level of pain and temperature and simple touch is carried by spinotectal tract through three order neurons. The first order neurons are collaterals from lateral and ventral spinothalamic tracts to the main sensory nucleus. Second order neurons are the cells of the main sensory nucleus in the posterior horn of the gray matter. Their axons cross and ascend in the lateral column as the spinotectal tract to terminate in the tectum of the midbrain. Third order neurons are the cells of the tectum of the midbrain. Spinotectal tract carries pain and temperature and simple touch. Some fibers, however, carry visual reflexes and in the superior colliculus of the midbrain.
بسم الله الرحمن الرحيم.
ولا تحسبن الذين قتلوا في سبيل الله أمواتا بل أحياء عند ربهم يرزقون